Okay, so guys, this is where we're going to start. This is the homework assignment that we should have reviewed when I was here Monday, but I wasn't. Obviously, this is the assignment over the polyatomic ions. And then we also included the idea of solubility that's going to be very important today. So guys, I would like to talk with you about number 15 in the left-hand column. But then if there are others that you would like to talk about as well, I would be more than happy to do that. But guys, focus on number 15 in the left-hand column with me, because this idea is going to become very important relative to the lab today. So guys, looking not at your answers, but look at the questions. Looking at number 15 in the left-hand column, guys, the salt that you are asked to write the chemical formula for is gallium-3 chlorate. You should have a really big problem with me asking you to write the formula for gallium-3 chlorate. Did any of you pick up on why? Guys, look at gallium on your periodic table. Gallium is element number what? 31? So guys, now looking at number 31 on your periodic table, let's remind ourselves again that the question was gallium-3 chlorate. Looking now at gallium on the periodic table, do you now see the issue? Yeah, guys, gallium can only be +3. And because gallium can only be +3, it should not have a Roman numeral. So guys, number 15 should actually just read gallium chlorate and not gallium-3 chlorate, because gallium only can be +3. So then maybe you're asking, if that's true, then why, Knappenberger, did you make the mistake? And the answer is because I wrote up this assignment off of my periodic table that's like the one that's on the wall, which is a little bit older than yours. And guys, I know you can't see this, so you're just going to have to take my word for it. Guys, my gallium also has a charge of +1. And actually, yours is a typo. Don't change it. But guys, gallium actually can go +1. That's why I put the Roman numeral. But given the data that you've got, you don't need the Roman numeral because gallium can only be +3. So it's a small detail, but it's an important understanding, and I wanted to mention it to you. So guys, what do you need to talk about? Go ahead. Ladies first. Oh. Which side? Okay, hold on. Let me zoom down there. So guys, the question is 31 in the right-hand column. Is it about the acetate? Okay. No. Neither. So here's what's going on. Guys, the question is number 31 in the right-hand column, and this is what's going on. When you first learned about acetate, way back when, you learned that the Lewis dot structure for acetate actually looks like this, and it was the one that you had to memorize and all that other stuff, right? And so when you learned this, you learned that acetate actually had this formula, because this formula tells us this structure, okay? But understand that you can also condense this. We've got 2 carbons, 3 hydrogens, 2 oxygens. So you can go C2H3O2 and mush that all together, and then you lose information, right? Because you no longer know that this is what it looks like, but it's the same substance. So if I won't do that to you on the test, understand that I actually lifted this off of somebody else's webpage, and so understand I'll write it out for you, but that's what's going on. What else, y'all? You really okay? You're good? Your questions are satisfied. Okay, then don't forget, guys, to make a note to yourself to record this tonight, but that is only half of what we need to address. So, guys, let's switch over to assignment number 3. Putting this away, here then is assignment number 3, which looks like this. And guys, I'd like to take this a page at a time. Again, this is the material that you learned from the screencast. I think that probably went well, especially given that none of you came and asked questions. But guys, we got to make sure we're okay on these. So the first page was just writing the formulas and the names for molecules. Remember that when we do that, we use the monos, the dis, the tris, and all of that stuff. Guys, the only rule that you need to keep track of is if there's only one of the first element, you do not put mono. That's the only place you will not use a prefix, is don't put mono if it's the first element. Notice though, guys, that you do put mono if it's the second element, and then what you do with vowels like monoxide or condensing that to monoxide. I'm not going to get real caught up in that. But guys, understand these are two words and not one. And guys, your answers should look just like mine. So what questions do you have on just this page? You okay? So guys, with that said, I think that you would agree this is where these get tricky. Understand that you will have more practice on these because, well, I'll talk to you about Tuesday in a minute. You will have another day to practice on these. But guys, traditionally, this is where this gets hard for people because now you've got to be able to take everything that you learned in the previous 2 days, mix that together with what you learned last time, and then figure this out. Just a second. So, guys, big idea is this. Whenever you're doing these mixed sets of salts and molecules, the first thing you do is you look up the first element. If it's a metal on the left-hand side of the periodic table, then you're in salt mode. If it's a non-metal, then you're in molecule mode. Guys, remember salt mode is all about Roman numerals and parentheses and least common multiples. And then molecule mode is all about prefixes. So go ahead.
So for number 10,
on this page?
yes.
Yeah.
For S3, it says phosphorus dioxide. And then for number 11...
Wait, 10? This 10? It says P4? Oh, okay. Okay, I was like, if it says that, one of us is horribly wrong. Here, is that better?
Yeah, okay. I just didn't know that you said bases.
Yeah. Are we okay here?
You're good.
Okay. So, guys, any questions on either one of these pages? You're okay? Okay. So, guys, please, if you have not successfully completed this assignment, do not give yourself the pass. I will never know that you just went online and recorded your score until it becomes clearly apparent that you weren't ready for the test. So guys, don't just give yourself credit for this if you haven't successfully completed it, because you know as well as I do, if there's not a 0 hanging in the grade book, you will not go back and finish this. Guys, make sure that you hold your hand to that fire. If you need help, please let me know. A couple of your classmates came in after school yesterday and I sat down with them and they were like, oh my gosh, 10 minutes with you and all of a sudden I understand this stuff. Guys, I know that this is a weird year. I know that it feels like your teachers are holding you at arm's length because of COVID and Canvas and all this other crap. But guys, please come and talk with me. I will sit down with you. We'll order pizza and spend the night if you want. Guys, please come in and get help. I would love to help you be successful with these. So guys, please make sure that you record this as well. And you guys are good on questions? Okay, this is going. All right, so guys, let me get rid of this and let me grab a hold of this. And guys, just very, very quickly, let's calendar together so that you understand what's coming up. So today, guys, we're going to go do a lab. The lab is interesting and the lab is amazing review for the test. You're really going to like this lab. But the write-up is very, very detailed. So guys, here's the way today's going to go. Today we're going to go to lab. We're going to gather the data. When you're done, you'll come back and start writing up the lab. Then guys, when I see you on Wednesday, this is completely a work day for you. I have nothing, it's literally 70 minutes for you to get stuff done. But you will have stuff to get done. Guys, one of the things that you can be working on is the lab write-up. So across the top of your lab that you have in front of you, if you want to write, Tuesday, not Wednesday. Guys, if you want to write down due next Thursday, due a week from today, that might not be a bad idea. This is not due on Tuesday, it's due on Thursday. So if you want to spend some time on Tuesday writing up this lab, you can do that. Guys, in addition to that, In your homework packet, we also have a 4th review assignment, and we'll be working on that as well if you choose. So guys, the bottom line is next Tuesday is a big old day for you to get a bunch of good stuff done in preparation for the test. Could be the lab write-up, could be assignment number 4. Anything that you don't get done will become homework, and then you will address this stuff. It'll all be due on Thursday. So, guys, let's shift into the lab, but let's do questions first. Go ahead. No, there's 2 separate links. So what you'll see is for the polyatomic assignment, the first one we looked at, you'll notice it says nap and then due today, the 11th. So there's one link, and then the other is the molecules assignment, and you'll also notice due the 11th right here. So there's 2 separate links. Okay. Guys, any other just generic things you want to talk about before we talk about the lab? Yeah. Other way around. Molecules are non-metals, salts are with the metals. And so, McCade, just to give you an idea of what we're doing today, everything we're going to do today is salts. So the first element will be a metal. Yeah, and so you're going to see that today really reinforces this idea. Guys, you ready to shift gears and talk about the lab? Is that okay? All right, so let me get rid of this. Let me grab a hold of this. And guys, please write your name on the lab and literally nothing else. So guys, do not write anything on this lab as we get started. But guys, what I want to do is I want to set the stage for you today about how this lab works. So we're going to spend about 15 minutes together, and then we're going to get you over into lab. Guys, literally, please do not write any of this down. I'm going to do the lab in front of you. Your data will not be my data. So guys, just watch so that you understand what's going on. So guys, let me give you the preview for the lab. You ready? Watch up here. So guys, when you walk into lab today, the very first thing you do after you grab your goggles is you're going to come to the front of the lab and you're going to grab one of these trays. And in these trays are 6 different bottles. And in each one of these bottles, there is a salt solution. So for example, this is potassium hydroxide. This is cobalt 2 chloride, this is sodium hydroxide, this is cobalt 2 nitrate, this is table salt, sodium chloride, and then this is copper 2 acetate. So guys, there's 6 sets of this set. You'll notice that on the front it says set number 2, and there are 6 of these, and then there's also 6 sets of what we call set 1, and eventually you'll touch both of these. So guys, what you're going to do when you go into lab is this. You're going to grab each one of these bottles out of the set, and you're going to figure out what ions exist in these bottles. Remember, these are salts dissolved in water, and you're going to figure out what ions exist in these bottles. Then what you're going to do is you are going to react every bottle in this set with every other bottle in the set. So you're going to squirt this into all 5 of these. And then you're going to squirt this into all 4 of these, not into the bottles. Then this into these 3, then this into these 2, and then you're done. And you will have reacted every possible cross combination that you possibly can. Then guys, what you're going to do is that for all of the reactions that actually created a new product in your calculations, you're going to figure out what those products are. So guys, that's fundamentally what you're going to do in lab. But go back to the very first thing you're going to do. The first thing you're going to do is figure out what the ions are in solution. So in order to figure out what the ions are in solution, we need to remember how dissolving happens. So guys, let me grab this guy, NaCl. This is our friend table salt, right? So here's the question. What's inside this bottle? Because there's no table salt. What's inside this bottle if the salt is dissolved in water? Because there is no salt in here. Because there's no such thing as salt water. Because the salt dissolves. And when the salt dissolves, what does it break into? Let's take a look. So guys, remember we watched this video previously, but guys, this is literally what is inside of salt water. So when the salt dissolves, the positive sodiums and the negative chlorides are being drug off into solution by the water molecules. And guys, that's literally what's going on inside of this bottle. So when you grab a bottle of salt water, there is actually no salt in salt water. Guys, the NAs and the CLs have been separated, and so literally inside this bottle, you've got sodium ions and you've got chloride ions just floating around in solution. Which brings up kind of a weird idea. You know, it's actually the case that we've never tasted salt. Because we have no idea what salt tastes like. Because when we put salt on our tongue, it dissolves into our saliva. And the only thing that we know is what sodium ion and chloride ion taste like. It's actually impossible to taste salt, because to taste it, it has to dissolve and it breaks into ions. So all we know is what sodium ion and chloride ion taste like. Well, guys, that's pretty straightforward when you talk about NaCl. But this then becomes the question. What if we're talking about a little more complicated salt? So guys, what if instead of looking at NaCl, what if we're looking at cobalt-2 nitrate? Here's the question, guys. What does cobalt-2 nitrate do when it dissolves in water? Where does this break apart when the water attacks it? What are the ions that are floating around in this bottle of cobalt-2 nitrate? So guys, what is the positive ion in cobalt-2 nitrate? What's the positive stuff? Cobalt. What's the negative stuff? Nitrate. But here's where we've got to be careful, because cobalt nitrate is written like this. And guys, this is where you've got to be careful, because there's a cobalt ion and there's a nitrate ion. What does this 2 right here tell us? There's 2 nitrates, and guys, that's what we're seeing right here. There's 1 cobalt and there are 2 nitrates. So the ion types are cobalt and nitrate, but when they dissolve, we end up with twice as many nitrates as cobalts. So guys, literally, this is what happens. The water molecules come in and they grab a hold of these things, and when it dissolves, it literally splits apart into cobalt ions and nitrate ions. Yeah, there's twice as many nitrates as cobalts, but guys, we want to know the types of ions, so it's just cobalt. So our positive ion is cobalt, and our negative ion is nitrate, and we don't care about how many of each there are. Does that make sense? So guys, the big idea is this. When you're doing this in lab, it's not how many, it's what types of ions exist in solution. So guys, you settled on that background idea? Okay, so let's do some chemistry. So guys, here we go. Grab your labs. Do not write on them, but let me orient you to your lab reports. So we are not going to read over the procedure. I'm simply going to show you how this works. So guys, what I did is I condensed your data chart so that I've only got 1 data chart, and then I've got a little bit of the calculation chart down at the bottom. And so this thing looks like so. So guys, let me explain to you then the way that this lab works. Please, guys, do not write any of this down, just watch. So guys, imagine that I'm you, and I'm stepping into lab, and I'm now doing this lab in front of you. So guys, here's what's going to happen. You're going to go up to the front of the room, you're going to grab a set of solutions. Then guys, the very first thing that you're going to do is you're going to write down which group you're using. I'm using group 2, so I write down group 2. Then guys, what you're going to do is you're going to start randomly grabbing these bottles out of the bin. So guys, say that the first bottle that I grab is cobalt nitrate, cobalt-2 nitrate. Guys, what are the ions in this solution? What's the positive ion? Cobalt. So guys, the positive ion here is cobalt. What's the negative ion here? Nitrate. So guys, what we're going to do is we're going to write this down. So bottle number 1, our positive ion is cobalt. Notice that we've got the charge, and our negative ion is nitrate. Now guys, we have a problem. Look on your periodic tables at cobalt. Guys, cobalt is element number 27. How do I know that cobalt was +2 and not +3? How do I know that cobalt is +2 and not +3? Split it in half. Nitrate's minus 1. Minus 1 times 2 is minus 2. So this is plus 2. Plus 2 divided by 1 is 2. So guys, it's the Roman numeral, and you determine that by working it backwards. See how this is great practice for the test? So guys, cobalt is plus 2. Go ahead, McKay. No, not if there's only one of them. If there's only one of them, it doesn't go in parentheses. And we'll show you some examples of that in a minute. Okay, so guys, that was bottle number 1. Now we grab another bottle, and this bottle says, oh my gosh, this bottle says KOH. What are the ions that are in KOH? What's the positive ion? Potassium. So guys, our positive ion is K. Look up the charge of K on your periodic table. Plus 1. Guys, what is our negative ion? Well, it's OH. Where are we going to find that? Periodic table or yellow sheet? Go get it. What is the charge of OH? Hydroxide, and its charge is? Beautiful. Okay, now guys, watch what we're going to do. So what we're going to do is for bottle number 2, our positive ion is potassium, our negative ion is OH. But now guys, watch this. Bottle number 2 is also up here, so we're going to write it twice. The cation is potassium, and the anion is OH. Don't forget the charges. So now guys, I grab another bottle. And the next bottle that I grab is CuCl2. Where does that break apart? Between the Cu and the Cl, so that's going to split there. So guys, what is the positive ion? Copper. But what charge do we use? Look it up on the periodic table. What's the charge of copper? Could be 1, could be 2. Which one is it? Work it backwards. Chloride is minus 1. Minus 1 times 2 is minus 2, so this is plus 2. So that would be copper with a plus 2 charge. But now guys, watch this. What is my negative ion? It's chlorine, but it's not 2. Guys, this 2 right here tells me that there's 2 of them. I don't know why I'm not drawing. Oh, it's tapping, sorry. So guys, this tells me that there's 2 chlorides, but those break apart. So I've only got 1 chloride, and then again I write it twice. My positive ion is copper, my negative ion is chloride. You get the idea? And you do that for all 6 bottles. Now guys, once you're done with that, here's where this gets interesting. Alex is going to understand this as a wrestler. Guys, what we just created is a round robin tournament. We are now going to mix up every bottle with every other bottle. So bottle 1 will mix with Bottle 1 will mix with 6, 5, 4, 3, and 2. 2 with 6, 5, 4, and 3. 3 with 6, 5, and 4. 4 with 6 and 5. 4 with 5. And now we've combined every single possible combination. Do you see how that works? But guys, what are you looking for? Well, here's what you're going to do. Because when you grab these bottles, what you're going to do is you're going to mix them together in a micro well tray. So you're going to go like this. You're going to be like, okay, bottle number 1 is my cobalt nitrate. And you're going to take some cobalt nitrate and you're going to fill this well half full with cobalt nitrate. Then you're going to mix that with bottle number 2, which is KOH. And you're going to come along here and you're going to put some KOH in there. And guys, you're going to look for a reaction to take place. But let me show you what you're looking for. Guys, what you're looking for is the formation of what is called a precipitate. So I'm going to do this not in a micro well tray. I'm going to do this in beakers in front of you so that you can actually see what this looks like. So guys, bottle number 1, this is my stock bottle. I'm going to do this even bigger. So guys, bottle number 1 is my cobalt 2 nitrate. Again, you're going to put drops in a micro well. I'm going to do this a little bigger. So bottle number 1 is my cobalt nitrate. And then guys, bottle number 2 is my KOH. But rather than just dump it straight in, I'm going to put it in a beaker first. Again, you're going to mix these together in a micro well tray. But guys, fundamentally, when you mix these together, what you're looking for is the creation of a new substance. Ready? Watch close. And guys, we just created a new substance, which is obviously a different color. It's purple. But if I just set this down here in front of Matthew and let it sit, you guys will see this. Well, here, let me hold it up. You can't see. Guys, can you see the chunks? You literally created chunks. These chunks are what are called a precipitate. So guys, we just created a brand new salt. Now here's the question. Does this salt, this blue stuff, dissolve in water? No, because if it did, it wouldn't be there. It would be dissolved, right? So guys, we just created a brand new salt that does not dissolve in water, and that's what these blue chunks are, and you can see them settling to the bottom and then also turning pink because they're actually rusting in front of your eyes. But guys, the idea here is that we created chunks. So here's the question. How are you going to know if you made chunks? And this is the easy way to figure it out. Guys, when you do this lab, do it, where did my tray go? Do the lab on top of your lab sheet, and if you cannot read through a cell, you created chunks. And then guys, all you do is this. The question is, did I create chunks? Did I create a precipitate when I mix bottle 1 with bottle 2? The answer is yes. So you just put a Y for yes, and you just keep going. So do bottle 1 with bottle 3. Did it make chunks? Yes or no? Bottle 1 with bottle 4. Yes or no? And guys, that's all you're looking for is chunks or a precipitate, and it's just yeses and nos. Then guys, when you're done with that entire set, you take your micro well tray, you dump it down the drain. All these salts are safe. You dump this down the drain, you rinse it out with tap water, dump it down the drain, get it really nice and clean, shake out the water, grab the other set, and do it all over for the other set. You get the idea? Okay. Then guys, when you're all done with this, it's then time to do calculations. Guys, this is the one thing that I want you to write down. Please write this down. When you're doing your calculations, only do this for the yeses. Guys, don't do this for the nos. Only do this for the yeses. So the question then becomes, what then are you doing? And guys, the answer is this. Watch really close. This is what's going on. Our goal in these calculations, oh my gosh, look, the whole thing rusted. That's really cool. So guys, our goal in these calculations is to figure out what are the chunks. That's why we're only doing it for the yeses. What are the chunks? So guys, let me explain to you the chemistry that took place and how to represent this. So guys, as you're writing this up, here's what you're going to do. So first of all, we're only doing it for the yeses. So bottle 1 and bottle 2 created chunks. So you're not doing this, but you're going to write it down. But you're going to write it down twice. Guys, notice that there are heavy black lines every other set. You're doing this for every other set. So bottom 1 and bottle 2. And then guys, let me show you what happened when we mixed these together. Literally, the chemistry that took place is when you mix these together, here's what happened. Guys, the positive ion, the cobalt right here, traded partners and grabbed a hold of the hydroxide. So guys, that's the first thing that happened was the cobalt hooked up with the hydroxide. So what you're going to do is you're going to write that down right here. So the positive cobalt hooked up with the negative hydroxide. But guys, what's the other reaction that took place? Well, the opposite. Here, the positive potassium hooked up with the negative nitrate. So guys, the other reaction that took place was the positive potassium hooked up with the negative nitrate. So we're going to write that down as well. So again, it's only for the yeses. Take the positive of one with the negative of the other, the positive of the other, the negative of the one, and put them together. Then guys, check this out. This now becomes exactly like your homework. Here's what we're going to do. Ready? Cobalt's +2, hydroxide's -1. Where do +2 and -1 meet up? 2. So how many cobalts do we need? 1. How many hydroxides? See how this is like your homework? We need 1 cobalt, we need 2 hydroxides. How do we write that? Like this. So remember, if you need more than 1 polyatomic, it goes in parentheses. Guys, this is just drawing on everything you've learned in the last few days. Then we need to name this. This is cobalt, this is hydroxide, but cobalt can have more than 1 charge, so we name this cobalt 2 hydroxide. We need the Roman numeral. And then guys, we do the same thing down here. potassium's +1, and nitrate is -1, so +1 and -1. Oh, did that really pause? I'm not sure. So guys, +1 and -1, we get KNO3, and then guys, that's called potassium nitrate. But notice the other thing we have to do is look up their solubilities. So guys, grab your yellow sheet and let's look these up. So looking up the solubility of cobalt-2 hydroxide, what letter do you see? Looking up cobalt-2 hydroxide, you see an I. And guys, looking up KNO3, potassium nitrate, you should see an S. So what then does this mean? And guys, the answer is this. The stuff in the bottom of this beaker is cobalt-2 hydroxide. The idea is that the cobalt-2 hydroxide is insoluble. We figured that out on the back of the sheet. The cobalt-2 hydroxide is insoluble, so yes, that is our precipitate. The potassium nitrate is soluble, so it is not our precipitate, which means it's still dissolved in the water. Lots of chemistry, right, guys? Grab your partners, work slowly and purposefully. Invite me into conversations if you need. If your lab partner is gone, feel free to join another group. Guys, we're goggles first. Everything you need is up front. And guys, remember that you will have Tuesday to work on these lab write-ups, but you also have a homework assignment to do. I would get as much of this done as you can before the weekend, but that's your call. You guys ready to go? Let's get next door.